This is Josh White with JW Math Tutoring. Today's video is going to cover some Desmos hacks from the Bluebook practice tests 3 and 4 that you can use to solve problems on the digital SAT math sections. So let's go ahead and take a look.
Life is a dream that calculus could never predict.
This is question number 20 from Bluebook practice test 3, module 1. And this basically deals with an exponential function. I'm going to show you how we can do an exponential regression to solve this question entirely in Desmos. So first thing we're going to do is make a table, and we're going to put some points in the table. The first point is going to be 0, 12,000. And the reason for that is because it says initially this bacteria colony has 12,000 bacteria in it. So initially means that time t equals 0. And that's going to be our x value, and the y value is going to be the 12,000. Then 4 hours later, so for a time equal to 4, the number of bacteria is going to be 24,000. So we can enter those both in. Now I can do the exponential regression, and I can use the same format, same letters, except in place of t, I'm going to put x1 because that's the variable I was using to represent the time. And so notice this will give us the value for C, the initial amount. I mean, we already know that it's 12,000, but also it more importantly gives us the value for R, which is 0.25. So the correct answer to this one is just letter B, 1/4. And you don't need to do any more work than that. Again, you can figure out the entire question just in Desmos. Now, next one is from the same test, Bluebook Practice Test 3, Module 1, question number 22. So on this question, which is a fairly difficult one, we again can do the entire problem in Desmos. So what I'm going to do is I'm going to graph y equals and then the left side of the equation and then y equals the right side of the equation. Okay, so where these two graphs intersect, let me zoom out here so you get a better picture, are going to be the solutions to this equation. So now what I'm going to do is I'm going to set my slider value for A to an appropriate value. So specifically here it says it's greater than 30. So I'm just going to choose 31. Even though it says it's a constant, it doesn't say it has to be an integer. It's just, it's easier to work with integers. I'm going to also set my step value equal to 1. All right, so now A is 31, so that part is met. And let's see what our two solutions are. So let's just zoom in here to get a better look. Okay, so we got one solution here of 29, and the other intersection point, or i.e. the solution, is at 32. I'm only looking at the x values, not concerned with the y values. All right, so far I've got 29, check, and my other solution is 32, but notice, since my a value is 31, 32 is just equal to 31 plus 1, i.e. a plus 1. So this one also appears to be a solution. So right now it looks like the correct answer is going to be letter C, 2 and 3 only, but let's just try a couple other values and just confirm that. So if I go to 32, notice the 29 stays, there is no change with that, but now the 32 solution moved to 33. And okay, that makes sense because my A value moved from 31 to 32. And you could also, again, go to 33, and you could see the 29 point is not changing. 29 is always going to be a solution. But the other one now, it jumped up to 34. So notice the solution is always one more than whatever my slider value is for A. So that just confirms correct answer here is letter C. 2 and 3 are solutions to this given equation for these, given conditions on it. So if we go back to Desmos, I think the easiest way to do this is just going to be to graph the original function, and now we can easily graph g of x with the shift. So let's go back to the home thing here. Okay, we don't need f of x anymore, so we can get rid of that so we're not confused. Okay, what are the x-intercepts for g of x? -5, -4, 0. Okay, so a plus b plus c, -5 plus -4 plus 0. Well, that's just -9. Correct answer is letter B, and we're done. We can move on to the next question. You could also technically have done this using a slider. So for example, if you just made this K, and then if you add a slider, okay, now, so if you zoom out, you see that like right here, it's way down here. In order to get no x-intercept, it's going to have to slide up a lot. So, but you would have to keep going, and eventually, you would find that it's at 50, but it might take you, a while to get there. So because it's free response, I mean, I probably wouldn't recommend that, but if you had enough time, you could do that and you could examine it because, especially because it tells you it has to be an integer, so you don't have to worry about it being a decimal value. Here is how you can do this problem in Desmos. You can save some of the work depending on the approach you take or all of it. So the first thing is once you get it in slope-intercept form, so let's say you get it equal to 9/10 x minus 19 over 10, right? Okay. So I graph that, but notice I define it as f of x. And then what I want to do for my new function is I want to take f of x and I want to shift it down 4 units. Okay, so I do that, and now what is my x-intercept of my new line? G of x. Oh, 6.556. There's my answer. Okay. So in this approach, you still have all of the work. Basically, like you're still doing all of the work, um, at least in the first half. You're not doing this, you don't have to do the second half of the work, but you still have to do like from here to here because you need to get it into slope intercept form. However, here's how you could also reason your way through this, doing the entire thing in Desmos, no work required. Okay, I graphed the first line. The original function I called f of x, right? Okay. So if it's being shifted down 4 units and we're looking for the point that's going to be on the x-axis, that means on the original line, which is technically shifted up 4 units before the shift down, I'm looking for a y value of 4. So if you just graph y equals 4 and you see where they intersect, like this is the point that when you shift it down 4 units, it's going to be an x-intercept because the 4 for the y coordinate is going to shift down and become 0. So this is how you could get the answer to this question entirely in Desmos without needing to rearrange the equation, um, and basically do any of the work with the fractions or anything. All right, question number 22. Here we have a circle. You are going to shift the circle down 4 units in the xy plane, and they want to know which equation represents this new circle, shifted down 4 units. So the easiest way to do this, honestly, is to go to Desmos and graph the original circle and just graph the answer choices and see which one shows you a new circle shifted down 4 units. So there's the original. Okay, there is the new circle. So let me just zoom in because to get a better picture of it. All right, so let's see here. This first circle has a point of 0.8 at the top here in the center. Okay, this new circle has a point of 0.4. Is that shifted down 4 units? Sure looks like it. This one has 0, -4 to 0, -8. So this is A is going to be the correct answer. You can try out the others. So like make this -6. Nope, here it went up technically by 4 units. And then for the last two, those are going to be shifting it left and right because it's the adding or subtracting the number in the x parenthesis. So you don't need to bother checking those. I'll just show you one of them, just to confirm. So x minus 4, quantity squared there. See, it shifted it to the right. And if you do +4, it's just going to shift to the left. So that's wrong. So again, correct answer is going to be, for this one, letter A. Now, so if you want to go, just to show you, go do this in Desmos. So I bring up Desmos, right? I'm just going to plot both things, and I'm going to put in a slider for A. All right, so now, first of all, you can see it's clearly way below it now, so I move it up to 10. All right, I need to jump it, even more. So let's keep going. Okay, so it looks like, so notice right here, I happen to get 14.6, and it's like so close. It's not quite touching it once, it's still above it, so it's got to be less than that. But notice 14.4 is below it. So now what I would do is I would go 14.4 to 14.6. I know it's between those, and do a step value of like 0.0, maybe 0.001. And now you can see, as you side note, it's getting closer, 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 closer. Again, you might have to zoom in here. Oh, look, 0.523 is too high. So keep going down, keep going down, keep going down. And this is how you can tell that right here that there's just one intersection, because it highlights, there's the gray dot when you click on it. Whereas if I was technically down here, notice when I try to click on it, there's 3 points, okay? So that is not one intersection point, or sorry, there's 3 points highlighted, meaning there's 2 intersection points and the vertex as well. So that's what tells you it's too low. Whereas if you're up here, see, there's an intersection point, but you have to like really zoom in just to confirm, yeah, it's not actually touching it once, it's really above it. So it's kind of a pain to do this in Desmos, but you can still do it and get the correct answer as well. Okay, here we have a problem from practice test 4, module 2B, the harder of the 2-second modules. This is question number 18, and this deals with doing basically regression on a rational function. So basically, this graph is of a function f. Then they take f and they do a shift or a translation on it, and they form g. And they want to know what the equation is that matches g here. So we can actually do this entire thing in Desmos, and here's how. First, I'm going to notice that there are multiple points here where it basically intersects right on integer values. So I'm going to go to Desmos, and I'm just going to make a table, and I'm going to type in these points for -7, -2, -6, -3, and then -5, -6. Now, I'm going to go ahead and do my regression, and I'm going to put it in the same format that it's given in. So that's a divided by x1, or x, but x1 in this case, plus b. All right, so let's scroll down. Okay, we have our a value and we have our b value. All right, this portion of the graph looks like, what we have on the screen here. So now what I'm going to do is I'm going to graph f of x, just filling in those numbers. So 6 on top, 4 on bottom. I'm going to get rid of this. I don't need it. Get rid of this. Now I'm going to do g of x, okay, which is technically shifting f of x to the left by 4 units. Now we can get rid of f of x. We don't need it. Actually, correction, we do need it because of the Okay, so now I can just turn off the graph of f of x, because we don't need its graph. Do need to still keep the function there, though. Okay, so now all we have to do is type in the answer choices and see which one matches. So answer choice A, 6 over x, does that match? Nope. 6 over x plus 4, does that match? Nope. Next one, 6 over x plus 8. Okay, looks like that matches. Notice how if I take this one off, I have this, and if I take this one off, okay, it still leaves the black one. So these are the same function. So the correct answer for this is going to be letter C. Again, we could do this entire question in Desmos, don't need to do any work to figure this out. Lastly, you could check D, but notice the x plus 4's just cancel out, so D is just really a horizontal line. It's just like y equals 6 if you graphed it out. So that's obviously not the correct answer. But here's how you could also technically get this in Desmos. I mean, this is a little more complicated, but still I want to show it just because, it is useful. So we go ahead, we graph out the function. All right, we're going to add a slider for both A and B. And I'm going to adjust the sliders. All right, whatever. I'm going to, actually, no, we'll do it this way. Let's see, is that, yep, that's directly on 2. Okay. So the product of the solutions is equal to K times A times B. So the two solutions I have are negative 0.175 and negative 2. Negative 2, negative 0.175. I multiply those together, I get 0.35, okay? So my product of the solutions is 0.35. That is equal to K times A times B. Well, what's A times B equal? Well, I said B is 2, A is 10. So that's just equal to K times 20. And now you could divide both sides by 20. So K equals whatever 0.35 over 20 is. 0.0175. Now, notice that doesn't give me anything that matches the answers exactly because this 0.175, negative 0.175, is rounded. I didn't like extend it out enough with enough decimal places. But we can still look at these answers and figure out like which one is that makes sense. What I mean by that is, okay, it's obviously not 57, it's obviously not 1. Is 1 over 19 equal to this number? No, it's 0.0526 whatever. So obviously B is wrong. So by process of elimination, it's A. And if you do A, notice it's pretty close. It just has more decimals. You know, it's 0.0175, 438, blah, 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 blah. But still, we know that A has to be the correct answer. So that's how you could do this entire problem, again, in Desmos as well. Here's an alternate method you can actually use to solve this problem entirely in Desmos. Now, this part of the video I recorded after I recorded the initial solution to number 22, you know, doing it by hand. And so I actually discovered that you could do this problem entirely in Desmos, you know, after the fact. So I'm just adding this in afterwards. So here is what we can do. So first, bring up the Desmos calculator. Okay. So I'm going to add a table and I'm going to add the points 9. I'm going to add 9, negative 14. That's my vertex. And I'm going to add 2 more points. One is just going to be 9 plus d comma 0. That is one of the x-intercepts. The other one's going to be 9 minus d comma 0. So basically, if you think about it, you have the vertex at 9, negative 14. Then you have your 2 intercepts, which are symmetric, meaning one is to the right by some distance from 9 and the other's to the left by some distance, but I know that their y values are both 0 because it says in the problem it intersects the x-axis at 2 points. All right, so now I'm going to do a linear regression. Now, notice so far nothing's happened. I don't have a graph. So what I have to do though is I'm basically going to add a slider for the d value. So let's just say d is equal to 1. Okay, so now I've got a graph. Now I've got values for a, b, and c. And notice here it says which of the following could be the value for a, b, and c. So what is a plus b plus c equal? All right, it's some gigantic number. All right. What about if I go, you know, if I go negative? Well, the numbers get smaller. What about if I go positive? Notice as I increase it, the numbers are starting to get smaller and much closer. As it gets wider, the numbers are getting closer to these values in the answer. So I go up to 10. All right, it's at negative, but it's not quite at, you know, anything that's in the problem. So let's just, whatever, jump it up to 50. Okay, so notice we're starting to get close to negative 12. Now, we can't, it looks like here I'm over negative 12. But if I go back here, I'm under it. So it looks like when my d value, i.e. the distance that the intercepts are to the right and to the left, is between like 21 and what, 21.3? Yeah, between 21 and 21.3. it looks like it will hit negative 12 somewhere. So that's basically confirmation that D is the correct answer. But here's how you know that for sure. Let me just zoom out here so we get a better picture of the graph. Notice as I continue to increase, okay, even up to 50, let's just jump it up to 500 and I'll set the step value just at 5. Okay. Notice as I'm scrolling, it's negative 13.9 and it's getting really, really, really close, negative 13.995. It's getting really close to negative 14, but it never actually hits it. Even if you scroll to like 10,000, and I'm just going to set the step value to 100. Whoops, there we go. Okay, notice it's getting negative 13.9999999, and it's getting real close to 14, negative 14, but it never actually hits it. So this is confirmation that A plus B plus C could be negative 12, and it cannot be any other values. Again, this is how you could solve the entire problem in Desmos, really without any work. Again, just to quickly review, what I did is I made a table. I entered in the vertex point. I entered in the 2x intercept points by doing 1 plus some slider value for D, 1 minus that slider value for D off of the x coordinate, the h value of the vertex, did a quadratic regression, and then I moved my slider values for D to see basically what the values of A plus B plus C would be, would be equal to. And I saw that it goes across negative 12, but it does not touch or equal any of the other numbers.